Hi, I'm Benedict. I'm a co-founder of Foursquare Tutoring, and this is problem 13 from the 2023 AMC 12A. It also appeared on the 10A, and it was problem 16 there. It reads as follows. In a table tennis tournament, every participant played every other participant exactly once. Although there were twice as many right-handed players as left-handed players, the number of games won by left-handed players was 40% more than the total of games won by right-handed players. There were no ties and no ambidextrous players. How many games were played? Let's say they're T total players. Then we have to choose two of them to play against each other. So the total number of games played is actually just T choose 2. So one of these answer choices, or more than one of them, would have to be equal to something choose 2. Right? Because we have 15 is T choose 2. And of course, this is just equal to T times T minus 1 over 2. And T times T minus 1 over 2, multiply by 2, 30, T times T minus 1. We have to have 6 and 5. Unfortunately, that works. We can't eliminate that one. B, 36 is T times T minus 1 over 2. 72 is T times T minus 1. And 9 times 8 works for this. Again, 45. We could just skip the multiplying by 2 part. We just have 90 is T times T minus 1. And T is 10 works. 10 times 9. This is not going the way I want it to right now. 48. 48 is T times T minus 1 over 2. That means we'd have to have 96 is T times T minus 1. Now, this can't work, right? Because we could have 12 times 8, 16 times 6, but you can't really get any closer than that, because then you get 8 times 12, and that would get funky. So we can eliminate choice D, finally, and 66. We have 132 is T times T minus 1, and this is just equal to 12 times 11. This 12 choose 2. So we've eliminated one choice. Nice. If the total number of games played is 40% more, or the total number of games won by left-handed players was 40% more than the number of games won by right-handed players, we could have like left win is equal to 7 over 5. This is just a 1.4, or 40% more, times the right-handed players, R win. Then we can get an equation in terms of the total also. Because there are no ties, we have either a left-handed player wins or a right-handed player wins. So we could add left win plus the right win. This must be equal to T. Now, just combine this over one fraction. That is 12R win over 5 equals T. And since everything has to be an integer, we can multiply by 5 over 12 to get the number of wins from a right-handed player is 5T over 12. Now, right away, this gets rid of choice A, because 5 times 15, it's not even, so it can't be divisible by 12. Same thing with E, because E only has one factor of 2. If we divide out by 12, we'd have a fraction, because 12 has 2 factors of 2. And, of course, 45 is odd. So multiplying it by 5 doesn't give it any more factors of 2, so dividing it by 12 will still not result in an integer. And just to be sure, we check B, 5T over 12. If T is 36, we have 5 times 36 over 12. That's 4, so that means we'd have 20, and that works fine. So the only answer that could work is choice B.